Now we take a look at example 2. The question says, determine the mass of carbon 4 oxide produced on burning 104 grams of ethane. And we were given the relative atomic masses of the individual elements. Carbon is 12, hydrogen is 1, and oxygen is 16. So, having this, let us take a look at how to solve this question. Like we said before, dear students, when you're given any question under stoichiometry, the first step is to ensure that the equation is balanced. If it is not balanced, then you ought to go and ensure it is balanced. So let us take a look at our equation first and foremost, and we can see that it is not balanced. So we have to balance the equation first. Next, when you are given a question, you ought to check for the two species you're most interested in the question. So let us take a look at our equation first. C2H2 plus O2, that gives us CO2 plus H2O. And if we are to balance that equation, we need to check for our individual elements, just like we have done before, from the right hand side and the left hand side. So looking at that, carbon at the left is 2, hydrogen at the left is 2, oxygen at the left is 2. At the right hand side, we have carbon 1, hydrogen 2, and oxygen is 3. So how do we go ahead trying to balance that equation? To balance it, therefore, since carbon is 2 at the left but 1 at the right, hydrogen is 2 at the left and 2 at the right, so it seems to be balanced. But in trying to balance those that are not balanced, we may alter that of hydrogen. So let us have that at the back of our mind. And if that is done, we will still have to provide coefficients that will balance hydrogen. Now, oxygen is 2 at the left, but it is 3 at the right. So let us look at ways to balance this equation. We may choose to say, let us place 2 in front of carbon. Carbon will now become 4. And if that is the case, we place 4 in front of carbon, 4 oxide here, so that carbon will now become 4 too. So since carbon is now 4 at the left and 4 at the right, the 4 at the right hand side has also affected oxygen. Oxygen will now become 4 times 2. Oxygen now becomes 4 times 2, which is 8. And don't forget, we have another oxygen here. So we are having 9 now at the right hand side. So since oxygen is now 9, but it is 2 at the left hand side, the 2 we placed in front of carbon at the left has not only affected carbon, it has also affected hydrogen. So that is now making hydrogen to be 4. So hydrogen is now 4 at the left, and we can make hydrogen to also be 4 at the right, and we're trying to shift that. So to do that, to balance hydrogen, we can go ahead to place 2 in front of hydrogen. So hydrogen is now 4, just like hydrogen at the left hand side. So that has not just only affected hydrogen, but it has also affected oxygen. Oxygen is now going to be 2 at that point. Oxygen is now going to be 2 and no longer 1. So oxygen is now 2 this side, and it is 8 this side. So in a nutshell, oxygen is 10, 2 and 8. So since oxygen is 10, that will make us to go ahead. At the left hand side, we place 5. At the left hand side, we ought to place 5. Okay. Let us bring this down a little. So there we place our 5. So looking at the equations now, we observe that it is all balanced. So we have 2 moles of ethane plus 5 moles of oxygen to give us 4 moles of carbon 4 oxide and 2 moles of water. So with this, the equation is now balanced. Carbon is no more 2 at the left. It is no more 2 at the left, but 4. So this goes. Hydrogen is no more 2, but 4. Oxygen is no more 2, but 10. At the right hand side, carbon is no more 1, but 4. Hydrogen is no more 2, but 4. And oxygen is no more 3, but 8 plus 2, which is 10. And 3 goes away. So this is the balanced equation. So we have just balanced our equation. That is the first step in any question given to us under stoichiometry. Now the next step is to check for the 2 species we are most interested in. Yes, the equation comprises of 4 different species, but we are not interested in all of them as at this moment. So we are going to be looking for the 2 most important species we are interested in that equation. And going by the question says we should determine the mass of carbon 4 oxide, CO2, produced on burning 104 gram of ethane. Dear students, I'd like us to understand that once we are able to comprehend the question, understand the English involved in that question, you will be able to interpret your solution even by yourself before starting up any calculation. Now, looking at the question, they require us to calculate the mass of carbon 4 oxide. And this mass of carbon 4 oxide we are required to calculate, we are told is produced when 104 grams of ethane is burnt. So it entails that we burnt 104 grams of ethane and some mass of carbon 4 oxide is produced. So that mass of carbon 4 oxide that is produced is what we are required of. That is just a simple question. So what we need to do is to say, from the equation, from the balanced equation, how many mass, what mass of ethane will give us so and so mass of carbon 4 oxide. So from the balanced equation, let us check for the mass of ethane when burnt under oxygen with oxygen. What mass of ethane will give us the mass of carbon 4 oxide. So that is what we are going to check for first. When we check for that, then we now return back to our question and say, okay, if this mass of ethane will produce this mass of carbon 4 oxide, then 104 grams of ethane will produce X grams of carbon 4 oxide. And that is how to solve questions under stoichiometry. It's just so simple and straight to the point. The first thing is just to get to understand how to balance your equations and then get to understand the 2 important species you are interested in as the question is presented. Okay, so from our balanced equation now, we'll observe that we are most interested in ethyne and carbon dioxide. So oxygen and water are not necessary as that the question goes for now. So we are interested in ethyne and CO2. And don't forget, having balanced the equation, ethyne has 2 moles and carbon dioxide has 4 moles. So from the balanced equation, these are the 2 species we are interested in. So we are going to say, now from this balanced equation, what mass of ethyne produces what mass of carbon dioxide? That is to say, how many carbon dioxide, what mass of carbon dioxide are we going to get from this given mass of ethyne, from this balanced equation? So that will make us now to go ahead calculating their relative molecular masses. So let's calculate the relative molecular mass of ethyne and that of carbon dioxide. And from our question, their relative atomic masses of the different elements are given to us. Carbon is 12, hydrogen 1, oxygen 16. So let us proceed. To do that now, we have to say 2 into carbon is 12, and there are 2 atoms of carbon there. So this is going to be 12 times 2 plus hydrogen is 1, but there are 2 atoms of hydrogen there. So this is going to be 1 times 2. Close the bracket. And then for carbon dioxide, we have 4 moles outside. Carbon is 12 plus oxygen is 16, but there are 2 atoms of oxygen there. So that is going to be 16 times 2. We'll close our bracket. So this now, we have 2 into 12 times 2 is 24, plus 1 times 2 is 2. Close our bracket. And then for carbon dioxide, we have 12 plus 16 times 2 is 32. Okay, let's proceed. Looking at that, we now have our next step. Let's take this up a little. So we have, so this is fine. That is fine now. So we proceed. We have 2 into 24 plus 2 gives us 26. And we have 26 here as against 4 into 12 plus 32 gives us 44. So that is what we have there. Now 2 times 26 will give us 52 grams as against 44 times 4. 44 times 4, that gives us 176 grams. So this is it. We are almost there. So what it simply means is that from the balanced equation, 52 grams of ethyne will produce 176 grams of carbon dioxide. That is what it implies. So now we'll now say if 52 grams of ethyne, C2H2, let's make this clearer. C2H2. So what we need to just say is if 52 grams of ethyne from the balanced equation produces 176 grams of CO2, then 104 grams of ethyne will produce X grams of carbon dioxide. That's all. And then what we need to do is cross multiply. Once we cross multiply, we get our answer. So cross multiplying now, we have it as 52 grams times X equals 176 grams times 104. And that will give us 52X is equal to 1818304. And by the time we check for the value of x by dividing both sides by 52 to make x our subject of formula, we have x to be 352 grams. So, and x is for carbon 4 oxide, so it means that carbon 4 oxide produced is 352 grams. So, when 104 grams of ethyne is burnt, we will have 352 grams of carbon 4 oxide. So, this is how to solve questions under stoichiometry. It's as simple as ABC. So, we take a look at what we have just done. Let us take a look at what we've just done. So, that is our answer. It's as simple as that. 352 grams of carbon 4 oxide.